Circumference of a circle is another word for perimeter. Okay, so perimeter, we normally talk about straight lines, but circles curve, so we give it a name. This distance around the circle is called circumference. Okay, so for those who don't know, can you please just write next to this and write perimeter? That's what it means when they ask you for the circumference. It really just means perimeter, so distance around the circle. In order to calculate this formula or to use the formula, you need to know two key terms: diameter and radius. What does diameter mean again? Hands up if you know. What is diameter? Yes, Attila?
No, I just started thinking.
Oh, you were thinking. Sorry, my bad. Anyone know? Oh, wow, cool. Well, then I guess I can teach you something. When we're talking about a circular shape, so like a tree branch, if you ever call up people to come and cut your tree branches, one of the first questions they'll ask is, how thick is your tree branch? Because the thicker it is, they bring different tools. You either bring a chainsaw, or you bring one of those snippers, or like one of those tree cutters. The diameter matters, but a lot of people don't actually speak in that language. They don't actually understand it. But the proper way to best measure it, how do you measure a thickness of a branch? See, the best way to measure is from one end to the other end. But here's the problem. Not all end to ends are the same. See, in a circle, if I said from this to this point, that's end to end. But where's the thickest point of my actual circle? So in the branch, how do you calculate the best thickness or the maximum width the branch has? It's actually from the center to center. It has to be cut directly. That's clearly longer than this length. So when we talk about diameter, what they're actually asking is, what is the biggest width that you can cut in this circle from one point to the other point? So one of the definitions is it has to cross through the center. Otherwise, you're not actually getting the full width of a branch. Does that make sense? Okay, so that's why we call it the diameter. So the diameter is not that length I just drew. It is the one that crosses from one end to the other end, but it has to cross through the center. If it doesn't cross through center, it's not the thickest point of the branch. That will tell you how far it is. So the distance is the distance from the center of a circle to the other end. Okay, so it's end to end. So notice it's one point of a circle to another point in the circle, but it has to pass through the center. Because if it doesn't pass through the center, you can do end to end, and that's not the thickest point of a tree branch. You could also do end to end from here to here. It only gets smaller. You can do it from here to here, but it's not the thickest point. So we want to know, when you say a diameter, it should actually represent the thickest, the maximum length of a tree branch, or a cylinder, or a Coke can. There has to be the maximum width that you can have in a circle. Unlike a rectangle, see, a rectangle stays the same throughout, so you only need to know one side, then you know the rest. The problem with a circle is it's not the same for every single point. Okay? So that's diameter. What is radius? Radius is, what if you don't need to know the full distance, because it's really hard to measure. Let's say a circle oval. An oval, you don't want to go from one end of an oval and then run all the way across, even though you get to the center. That takes too long. So one of the other ways that we can calculate it is you only need to know from one end of the circle to the center. Because that's all you need. Because in a circle, it's symmetrical. So if you know this length, well, then you know the other length. Because they're symmetrical, it should be the same. So it's really double the radius would make one diameter. That's the reason why we know radius. Okay, radius is just easier to calculate. We like radius because you only work half as hard. Otherwise, everyone will be measuring diameter. It's not easy to do. Yeah, so it's easy to measure radius. So radius is distance from the center of the circle to one end. Okay, or if it helps you, radius is equal to half of diameter. So diameter is the full width, the maximum width of a branch that you can have. Radius is just halfway because it's easy to calculate, but it has to cross through the center. Okay, otherwise you could have something like this. That's halfway, but that's not the radius because then you can't calculate the diameter from there. Okay, so double of the radius should give you the diameter. So another way of writing it, if it helps you, write this down as well. Diameter, capital little d, diameter is equal to 2 times the radius. So if you know the radius, you'll know the diameter. If you know the diameter, you'll know the radius. Cool? Just have those two notes. Here's another nice thing about circles. When you do a full revolution, what's the total angle? 360. So it's the angle out of 360 degrees. And then finally, circumference is the perimeter around the circle. So those are just the languages. So when we ask what is a diameter, what is a radius, it's just knowing how do you calculate the maximum width of something that's circular. Okay. Here's a formula. Now, in your textbooks, they don't give you this formula. I'm giving it to you because it's more advanced. It can help you calculate partial circles as well, not just a full circle. The typical formula is this one. They normally give you 2 pi r. Okay. Why is it 2 pi r? Because 2 times r, what does double the radius equal again? Diameter. So another formula is pi times the diameter will give you the circumference. Out of curiosity, anyone know roughly what pi is equal to again? 3.14. 14th of March. Okay, 14th of March is Pi Day because 1403, yeah, so 3.14. So 3.14 Pi Day. What is this 3.14? Shh. Thanks, team. We said that the circumference is the distance around a circle. What they're saying, and you can actually test this yourself as well, if you get something that is perfectly circular, which this is not really perfectly circle, but we'll be close to it. You take something like this,
try again.
Find the center, which in this case there's actually a center for you to see. Get a string. Get a little string. Measure from one end of the circle, doesn't matter where, cross through the center, and then to the other point. Cut that rope or string. Take that string, and then see how many times does it wrap around the circle. So if you take the diameter and you see how many times it wraps around the actual circle, and if it's a perfect circle, it'll be 3 and a bit. That's why they're saying, if you know what the diameter is, times by 3 and a bit will give you the distance around a full circle. That's the formula for perimeter. Okay, so that's what pi is. Pi is calculating the ratio of your diameter, how many diameters fit around the circle. And if it's a perfect circle, it should fit about 3.14. So it goes on. Okay? All right. So here we go. Now pi, in your textbook, they can use 3.14 and they can use 22 over 7. But you only use these numbers if they say approximately. If your question does not say approximately what is the value, you do not use 3.14. That means on your calculator, you actually have to use the pi symbol. Okay, so you have to know where the pi symbol is on your calculator and use that because there's a difference. You see, if I did this, if I took the numbers now, see what happens when I do 3.14 and I do times 0.1234. I'm just going to make up these numbers here. Yeah? That's my answer. But then if I take pi, oops, yeah, that's pi, and I times, oh, now I have to copy it down, times 0.1231253252453. Where's the difference? Anyone see the difference?
6. It's missing a 6.
Yeah. See, that's 3866, and this is 3868.
8 or 9.
Yeah, this one's less. Why is it less? Because you use the less number. Because pi is not exactly 3.14. It's about 3.41452, whatever it goes on, right? So if you don't use the actual value, this is an approximate answer. This is the better answer. So in your textbooks, especially Year 12, each decimal matters. So my Year 12s today had their first exam. These are the kind of questions. If they put their answer as 6, they lose a mark. They put 6.8, that's correct. They put 6.7, it's wrong. It has to be exactly 6.8. Okay, so that's why they have to use what we call exact values. Use the pi button. Don't use 3.14. Only if they say approximate. Okay, so if they say approximate, they'll tell you to use 3.14 or they'll tell you to use 2217. Do what they tell you to do. Okay, so in this case, pi is equal to, let's see what pi equals to. That's roughly 3.14159. 3.1415926. I'll just stop there. Okay? All right, so today's lesson notes. What did you learn? Diameter, so knowing the definition of diameter. Radius, circumference formula, there's two of them. One is pi times the distance, the diameter, sorry. And diameter we know is twice the radius, so that's why it could be pi times 2 times r. Okay, two formulas. So today's lesson, you're only going to use these two formulas and a calculator, and make sure to use the pi symbol. Don't use 3.14. Use the pi symbol to calculate. Let's do an example. Get out your calculator out. Let's do an example. Here's a circle. What is the diameter for this example? Can I please have, let's go with Attila. What's the diameter?
Is it a half?
16.
Oh yeah, radius is half.
Radius is half of that. So what's half of that? 8. Very good. So, right, diameter again is going from one end to the other end. So thickness of a tree branch, but it has to cross through the center. Okay, make sure it has to cross through the center. So it's 16. And a radius is a quicker way of calculating the diameter. Because it's symmetrical, if I know this is 8, then I can just double it. Then I'll know this side is 8 as well. So 8 plus 8 is 16. So in reality, when you have a really big circle, it's much easier to just calculate the radius rather than diameter. Okay, that's the reason why, because it's symmetrical. Angle. Angle, well in this case, we are looking for the circumference. So we are looking for the full circle. We're not looking for the distance of half a circle. If I asked you to run around this oval, you actually have to run a full 360 degrees. Okay? Now let's use the formula. The initial formula I gave to you was 2 times pi times r times... Now I gave you this. Now I didn't explain this bit before. This extra bit is a year 9 content. That little extra bit is year 9. So you take that off, it's year 8. You put it on, it's year 9. That's the difference. What is this bit? This depends on how much of the circle do you want. So if you only want 180 degrees of the circle, how much is that? What's 180 degrees out of 360? Half. That's why it's half a circle. So if I drew half a circle and I said find the distance around it, so from here to here, then you would then write 180 over 360 because you got half a circle. Okay? But in our case, we don't have half a circle. We've got a full circle. So let's put all the information in. It's 2 times pi times, what's my radius? 8, not 0. Times... For those who aren't sure what that little symbol I just drew, this is called theta. This symbol is called theta, which represents angle. Okay, so how much of a circle do I want? I want the full circle. So it should be 360 degrees out of 360 because I want the full circle. Okay? Type that in your calculator. Here we go. We had 2 times the radius is the diameter. Times pi, so this one we can type. This tells me how much of a circle do you want. Do you want full 360 out of 360? Or do you want half of it, which is only 180 out of 360? So different problems, the harder problems will have a partial circle. Okay, so here we go. Let's type this in a calculator. You should have 2 times pi times 8. So here we go. I'm going to do it. 2 times, use the pi symbol, pi times 8. And then I'm timesing. Now, depends on which calculator you're using. You might be able to get a fraction like I can. So you could get a fraction type 360 over 360. So that'll be good. If you can't do that, then do it this way. Brackets, 360 divide 360. Means the same thing. Okay, so that works as well. So if you don't have the calculator, we can do fractions the way I just did just then. That's how you do it. You put a brackets in to say that's a fraction. If you did it correctly, you should have 50.2654.
Where did I make a mistake there?
Let me see. It matters. You all have to get the same answer.
How? Everyone got 16 pi.
Oh, that's good. So then you press this button. Or you press second enter. Second enter. Oh, sorry, this arrow button.
Oh, yeah,
You
you
have to
got
put the arrow on.
gang got cool.
You have to put the arrow on.
So you convert what they call exact values to decimals. Yeah, you can borrow my one. You can borrow my one. Do you have this one? Yeah, this one.
Wait, what hours did you put these?
Yeah, so that's why
Roll
I'm
up
using
this.
this one. It's similar. It's the same. So we remember to use it.
Why is it so fancy?
That one.
All right, team.
Got it.
Let's go to the next example. Next example. Flip over. All right, let's go next one. Eyes near towards the board. All right, next example. This one says, again, you're going to calculate circumference, so you're finding perimeter. And this time it says approximation. So if they say approximation, in this case, they wanted you to use 22 over 7. Not the pi symbol and not 3.14. All right, let's practice again. In this diagram, what's the diameter? Can I please have Charlie? What's the diameter? Very good, 42. And the radius is what? 21, very good. So you can see from center to the edge, that's 21. So that means on the other side, which is symmetrical, it should be 21 as well. So double of 21. That's how we know diameter is 42. Oh, sorry, this is meters. Is it meters? Do we want a full circle or not?
Nope.
Yeah, we do. We want the distance around a full circle. It's a full circle. Yeah, that's a full circle. So 360 degrees is the full circle. Let's work out the formula again. 2 times pi times the radius times the circle, the angle of the circle.
2 times 21.
So here we go. 2 times, now it's not pi, because remember they said approximation, and they want you to use 22 over 7. So 22 over 7 times, what's the radius?
But isn't it like the same?
21 times. Now because you want a full circle, the angle is 360 out of 360. Because that's the full circle, 360 out of 360. All right, get yourselves ready, get your calculator out. If you punch in that correctly, you should get the correct answers. I will. So I'm going to put it on the side so you can see. So here's the calculation.
132.
All right. Nikki, do you have this page on as well? Because I can show you how to... Good. All right. Here we go. We do 2. Press 2. Times is over here. Times. Now pi is next to the letter H. So over here, next to the... You press that button next to the H. You get pi. Next to the letter H. This button is press pi.
2 times pi.
So you don't do 2 times 20.
Times. So you do 2 and then press the times button. And then pi. Yep. Times. Oh no, we're not using pi. Sorry, my bad. We're using 22/7. How do you do a fraction? This is how you do it. Press Control. Press Control and press divide. Yep, and then Control divide. So if you press Control divide, you should get a fraction template. 22/7. And then control this button. Control.
You can go like A, B,
And then
C,
divide.
X, Y.
And you should get a fraction
You can
template.
only get
Yeah. Type 22 on the top, type 7 on the bottom, and you can move it using
You
the
can't get one.
arrows.
You can't get A, B, C, D, F, G, H, I, J, K, L, M, N.
Alright, next one. Times 21 times 360/360. Let's see what we get.
Let's see what he does.
It's 130.
132.
Yeah.
Do you all get 132? Alright, good. You should get 132. Did you get 132?
Yeah.
Good.
41.
Did you?
Yeah, I get 130.
I'll come over and check. 132. Alright, I'm going to pause the video for a bit. I want you to try the next example and then I'm going to check your answers. Try B. I'm going to pause the video. Alright, team.
We'll just do
Last example. Here we go. So last example, you're still doing the same thing. Thank you. We're calculating the perimeter of this diagram. Now, this is the common one that students make a mistake. You see, the formula that I gave to you, listening, 2 times pi times r times the angle at 360 only gives you the distance around the circle. It doesn't give you any straight lines. It only gives you the curved part of the circle. Okay? So now, let's look at this again. In this diagram, they've given us 14. So this is the distance from the center to the edge. That's 14. Okay, so from here to here is 14. What information have they given us here? The radius. Very good. So we know that's 14. If you know the radius is 14, then what is the diameter? 28. Very good. Double it. Now, the next bit, to be careful. Angle. Do I want a full circle in this one? No. You see, I got this angle of a circle.
3/4.
3/4. And 3/4 is the reason because this is how much in terms of an angle? What's the rotation?
90.
So this is 0, 90, 180 degrees. What's this one? So starting from here, going all the way here. What's the angle?
270.
270. Yeah, so 90 plus 90 plus 90 gives you 270 degrees. And this is why you're correct. It is 3/4 because 270 over 360 is 3/4. See, 270 over 360 is the same thing as saying 27 over 36 because you divide both top and bottom by 10. And then what's a number that goes in 27, 36? 9. 9 goes into 27 3 times, and 9 goes into 36 4 times. So you know it intuitively as 3/4, but where did that come from? So that came from the idea that it was the angle that you want out of 360. Why is this important? Because next year, you're not going to get 3/4 and half a circle. You'll get something like this. They'll give you a shape that may look like that, and they'll say 248 degrees. Then you still have to do the same thing. So how do you do that one? With my formula, you can do. Okay? All right, team. Let's calculate this. So, if this only gives you the curved surface, what do you have to make sure at the end? What do you have to do once you get the distance around from here to here? What else do I need to add? What else am I missing? Because you're looking for the perimeter of this shape. What am I missing? Think about it. So if you use the formula, you're only going to find from here to here. I haven't fully gone around this shape. What am I missing?
Oh my god.
This one.
The radius.
From here to here, and then from here to here. You see, when we say around the shape, aren't you just running all the way here, then you're going to run here and run there. So if you start here, you've got to get back there. So this is the curved surface. The formula tells you the curved surface, but it doesn't tell you these two. So you have to add 14 and add 14. A very typical mistake in year 9. So here, let's calculate it. Remember to add the 2 radii at the very end. Okay, because you've got those extra 2 radii that you haven't accounted for. Okay, the circumference only tells you the curved surface. So circumference, you would be able to calculate as 2 times pi times 14, and you wanted 3/4.
Times pi.
Okay? Type that in your calculator to get just the curved surface. So this formula only gets you the curved yellow bit. Then you got to add on that blue bit, and you got to add on the blue bit to come back to where you started. So if you started here, that's the distance around the shape. Okay? So here we go. I'm going to write here, if I started here, then I better end at that same spot. So let's add it all together. Let's work out this bit. Type on your calculators. Here we go. 2 times pi times, where's pi? Pi times, what's the radius? 14 times 3/4 or 270 over 360. And then after you get the curved surface, plus 14 plus 14.
93.
Good. If you got 93.973, that is on the right track. So 93.97344. Now read the question. They said they don't want you to write your answer randomly. They want it to correct to 2 decimal places. So your final answer should be 93.97. Very good. You only take the first 2 decimal points. 97, and check if the next number is 5 or more. If it's 5 or more, you round the last digit up by 1. Otherwise, you leave it. So it's 97. Don't forget your units. 93.97 meters. Okay, so that's a typical exam question for year 8. For year 9, so I'll just change the angle, and most students forget those 2. Okay? That's it for today's lesson. 2 formulas. 1 concept. Find the perimeter of a circle.